Starting with June 2016 paper, yesterday I shared one file with you, which is all about practicals. The inorganic salt, usually the first question is about identification of the ions, and that is also related to memorization. Like you have to memorize the observations when you add aqueous sodium hydroxide or aqueous ammonia for two different salts. So inorganic salt A has one cation and one anion. Complete the table. Observe the appearance of A. It appeared to be brown. If a substance appeared to be colored, what this give an evidence or this give an idea? It gives an idea that there might be a transition element. So part of the part of a periodic table in which the metal element in A likely to found in. So which part, like we have S block element, P block element, D and F. Because it's a transition element, so where we can find this in a D block. Because the color compounds, whenever a compound is colored, it means it's a D block element. Dissolving A in a minimum volume of a hydrochloric acid and it form a yellow solution. The formula of the cation in A. So when we add hydrochloric acid, how we can identify what might be because copper can also dissolve with hydrochloric acid, iron can also dissolve. And as I mentioned here, so when we dissolve A in a minimum volume of a hydrochloric acid, concentrated hydrochloric acid, this is related to memorization. Like you have to identify if we add hydrochloric acid to an ion, what will be the color? If it is yellow color, usually it might be copper because copper 2 chloride is yellow, or iron 3. The formula for cation A could be, it might be iron 3 or it might be copper 2 because copper 2 and iron 3, when we warm with hydrochloric acid, as it form iron 3 chloride or copper 2 chloride, it will form a yellow solution. And this thing is written in the identification of the ions. Then when you add an acid, if we have these two ions, what will the color of the solution? Then gradually dilute portion of a B, gradually dilute a portion of a B solution with a distilled water. A yellow solution turn dark green, then pale blue. The formula of cation confirmed. So what might be the cation? First, it turned like yellow solution is there, it turned dark green and then it turned pale blue. So pale blue solutions, which compound is having a pale blue solution, which usually that is copper 2 ion. So this confirmed that copper 2 is there. When yellow solution was formed, it might be iron 3 or it might be copper 2. We are not sure. But once it turned a pale blue solution is there, this confirmed that we have copper 2. Place a sample of solid A in a test tube and heat it strongly. So we took a sample of A, we heated strongly, a pale green gas is evolved, which turned a damp blue litmus paper red and then it bleaches. So the gas is, which gas bleaches the litmus paper and a pale green gas, so that is chlorine. So we'll write here chlorine. And a white solid or a residue is left behind. So the anion in A is, so how we can identify, because we have to identify the anion here. So what actually A might be, we identify it was copper. Like the solution was like it were containing a copper ion, and because on decomposition it is giving out a chlorine gas, so might be a chloride ion as well. So chlorine gas is given off, so anion, the negative ion which is present, move towards anode, that will be a chloride ion. So Cl -1. And left white solid, So what actually happened, like if it was copper 2 chloride, when we supply heat energy, it will become copper 1 chloride and it give off chlorine. This copper 1 chloride, because copper 1 does not have an incomplete d orbital, that's why it appeared to be a white solid. And this was originally, when we are heating a sample, the red brown solid was copper 2 chloride. We make a solution in hydrochloric acid, it turned yellow. And when we dilute it, like we add water, as a result, it will become hydrated copper ion, which is blue in color. Then add dilute hydrochloric acid to a white solid, the color. So now we are doing a reversible reaction, like you have copper 2, we supply heat energy, it turn into copper 1 and it give off chlorine. Then add dilute hydrochloric acid to a white solid to obtain in D a colorless solution form. So when we add hydrochloric acid, a colorless solution is formed. The white solid is what? The white solid is copper 1 chloride, CuCl. And then we shake the mixture vigorously. The colorless solution turned blue. Why it turned blue? Because copper 1 chloride is, when we have a copper 1 chloride is colorless or a white solid. But when it becomes copper 2, it is oxidized as we shake vigorously. It is oxidized, copper 1 oxidized to copper 2. So the type of a reaction which result in a formation of a colorless to blue, that is, it is oxidized because copper 2 changes to copper 1. So this reaction is known as oxidation. So here we have oxidation reaction. Suggests a further test to confirm the identity of a cation, how we can make sure that there is a copper 2 ion present here. So the second test, one is we can add aqueous sodium hydroxide, that is already there. Second thing, what we can do if we want to test, we can add aqueous ammonia. First, it will form blue precipitate, and blue precipitate will dissolve to form a deep blue or a inky or a royal blue solution. So add aqueous ammonia. And as a result, what will happen? It will form the deep blue solution. First, it will form blue precipitate, which dissolves in excess. And when it dissolves in excess, it will form a deep blue solution. Then suggest a test to confirm the identity of anion. Anion was a chloride ion. How we can test a chloride ion? The test for chloride ion will add aqueous silver nitrate, AgNO3. And if it is a chloride ion, it will result in a formation of a white PPT or a white precipitate. And usually, whenever we test the halide ion, we first add acids, usually nitric acid. So first add acid and usually the nitric acid HNO3 is added, followed by adding silver nitrate, and it result in a formation of a white precipitates. Next is give the formula of the ion that give a yellow color to the solution and described in B, and a green color that is described in C. So what is the formula of the so again, as I mentioned, you have to learn this, that when complex of copper are formed, like you have a copper 2 ion is there in the solution, and we add hydrochloric acid. Like first, when copper is dissolved in the solution, it is surrounded by 6 water molecule. This is a complex. What we did, we add hydrochloric acid, HCl. The color of the compound might change due to change in oxidation number of uh, the element, or it might change as a ligand which is attached change. So whenever we add hydrochloric acid, like HCl is added, if 4 molecules of HCl are reacting, like 4 are replacing, so as a result, it will form Cu, Cl4 is there. and the charge will be -2. And what is the appearance of this one? This one is yellow. But if we add like the same compound, same complex was there, and we are adding HCl, as a result, when we add HCl, if three molecules or three chloride are replacing them, so it will form CuCl, 3 with a charge -1 overall, and that is responsible for a green solution. And this was copper, this will be blue in color. So copper can change its color due to change in oxidation number or due to a ligand which is attached. In this case, it is due to the ligand, like example, 3 chlorides are attached, then it will be green in color, 2 are attached. And the charge here will be -1 on this complex and charge here -2. So yellow color is due to this one, and green color is due to when 3 chlorides are attached.